In this video, we're going to see how to develop a serverless GraphQL API using a CLI tool called create-graphql-app that we see here in this GitHub page. We'll walk through the development cycle from bootstrapping the server to production by executing the CLI commands. We'll walk through the structure. So in order to install the CLI tool, we basically run npm install. I already have it installed, so we'll just run gga-v. It shows the installed version. Now we'll show the basic commands for bootstrapping the server. So the most basic command is gga, which is short for generate GraphQL-app. And we can see that the most basic command is the init command. We just clone an existing boilerplate project. We execute gga init and then the project name. We have a prompt to select from two available boilerplates. We choose the first one, which is a serverless API deployed on now-cli. The other one is aws-lambda option. And after the command, we have a cloned project with the installed dependencies. We now open it in a WebStorm. This is the project structure. We have services directory, which has like a business logic implementation, which we'll see later. We also have the schema as a splitted files structure for better modularity. This is a simple entity that we have implemented. We have query, mutation, and subscription for implementing our most basic API. And for each schema file, we have a matching resolver file where we have the basic implementation. And we'll see how this resolver file acts with the business logic later. And now we'll go on to see that the resolver files also have context. We have it as a TypeScript interface. You can see that we have PubSub Manager and the services that we'll see later. And this is the server main class. We have Angular style dependency injection. And we basically initialize it with Apollo server. And we'll start by building the server after creating it with the init command. One of the important steps in the building phase is that we generate TypeScript types from the schema files by using a tool called GraphQL code generator. You can see that the project structure also contains, we can see it here in the package.json file, that we have this codegen command where we have like the configuration file in a separate file of the server. This is the repository of GraphQL code generator, really great library for creating types. This is the type file that we have generated by running the build command. And as you can see, we use these types in the resolver implementation. You have like optional types to add. And then when we implement the logic of the resolvers, we have TypeScript security when developing the project. It's compile time warning and errors. So let's go on to continue to generating resolver file. This is the second command we're going to see. So in order to do that, we need to create our new schema file. We have a new entity in a separate file for better modularity, as I said. We create this file, have some basic station entity that we add here. And now we can simply go on. See, this is a very simple entity with mutation, subscription, and query. And usually what we want to do is to create a resolver file from the existing definitions. So we open a CMD in the types directory. We type ggr, which is a shortcut for resolvers. We select the type file and we generate it in the resolvers directory. We have station ts, execute this command. And now what we can see, we have a new file generated. We can see here in the resolvers directory, which has all the implementations for the server resolvers. And this is the basic layout that we have. Still no implementations, but we have basic signatures that we'll use later. We have the app context. We have the arguments for the resolvers. We can go on and build the server again. By the way, we run build win because I'm running on a Windows laptop. So we'll build the server again. It will generate the new types after adding the schema file. The CodeGen has generated types for us. And TypeScript has completed compilation phase. We can see in the types.d.ts file that we have new types for station schema. So it's really cool and nice here. We can go on and add the additional types for the resolver signatures. We can show that the station query returns a promise to an array of stations. We can also go on and add the optional typings that we have from the CodeGen for better development security, as I said. Now what we're going to do is we're going to return a new promise for a simple array of stations. We'll resolve it with a simple array. Now we also have the TypeScript defenses for us. As we could see from the schema file, we'll need the _ID field and the name. So this is what we're going to return from the resolver. Now what we're going to do is build the server again to generate the JS files from TS. And then we'll run the server and see that we have a station entity added to its implementation. So in order to run the server, we simply run npm start. We now have the Polo server up. That's it. We have the GraphQL playground, and we can see that we have added this station entity just in a few short minutes. But the next step that we're going to see that usually we don't want to implement our business logic in the resolver body. We usually want to have something like Angular services to implement the business logic. We have the resolver as a simple controller. Here we're going to execute a service generation command that is very simple, but creates a better separation of concern for the server development. We're going to take this short implementation, copy it, And we'll simply run ggas for service. This is the service name, station.ts. And by running it, we'll create the service file, but we'll also update some of the server definition files. We have, this is the class for, this is the file for the new service station service that we created. It's an injectable service that we'll use by with dependency injection right away. We can see that the server injector file, which contains all the definitions with injection.js, has been updated. Also, our context, our server context, has been updated to contain the new service automatically for us. Now it will be available for us in the resolver files. Before that, we're gonna create some basic constructor to the server. We'll try to use our server logger that is available in the boilerplate implementation. In order to do that, we have like a dependency injection style usage. We'll add a simple method for getting all the stations. Here it will be a simple promise, but it can be anything. It can be in order to fetch it from a remote API or from a MongoDB, anything you like. So we're going to add this method implementation. What we're going to do is simply copy what we had in the resolver file. This is our basic implementation. We'll operate some simple logging before returning the promise to see that we can use the injected logger service. And our next step will be to use this method from the resolver file. What we have here will replace the old implementation. Now the new service will be available on the context that is passed to the resolver signature. Now we'll simply use the function that we implemented on the service. Now we can see that we have the name as an available property on the args with the TypeScript useful defenses. Now what we're going to do is build a server again to check it with the new service. We'll let it build for 1 minute, and we're now getting close to the deployment to production stage. But first of all, let's see that it works on localhost. It's generating the types again and running TypeScript. Now we'll run npm start again. We'll refresh the playground. And you can now see that we still have the stations array available, but now we use it from a service, which is more suitable for business logic implementation. Our last step is to deploy it as a serverless API. For this, we're going to use now-cli. As I said, we can also use it on aws-lambda. But we'll see you'll need to install now-cli. But in order to deploy it, all we need to do is run ggad for deploy. It will run the deploy script that is available in the server. And then we'll have packaged the server, and it will be available on now servers in the address that we see here. We'll open it in the browser, and in this address /GraphQL, we'll have our API waiting for us, everything that we implemented. Very, very simple phase for deployment. This is it. We have our server ready, and just in a few minutes This is the documentation for the CLI. It's available on GitHub. And you can also see the boilerplate project on GitHub, the basic layout, the usage of the codegen, merging the schemas, and also the other boilerplate that is available is the GraphQL, the aws-lambda GraphQL implementation. It's also available on GitHub. And this is it. Thanks.